we proceed with subsequent processes. Sometimes a product will pass through different stages before it is finally completed. So to pass through process one, in process one there will be an input of materials, there will be an input of labor, it may be overheads, but it could be partially complete, or there could be part of it which is fully completed, part of it will need to go through another process for it to be completed. When it goes to process 2, it will need an additional input of either materials or just labor. So how then do you treat such a process? Most times the material input will have been completed in process 1. What is required in process 2 will be just the additional labor and additional overheads. So the labor and the overheads together will be called what? Conversion costs. So you just need the conversion costs for the output to be finally completed. We continue with the same example we've been looking at. This time we assume the output from process 1 is 920 units with a value of 110,400. So this is what goes to process 2. The normal loss in process 2 will be again 10% of good output, but there will be no scrap value. The output from process 2 will now be 900. Other inputs to process 2 will have additional materials of 20,600, conversion costs of 35,000, we are required to prepare an appropriate account given the above information. Can we attempt that before let's attempt it as an exercise. So the requirement is to prepare an appropriate ledger account given the above information. So we're going to open our T account. Our input units will be 920, valued at 110,400. The additional materials 20,600. The conversion cost 35,000. We're told the output is 900 and the normal loss is 10% of good output from process 2. Process 2 good output is 900, so 10% of 900 gives us 90,000 or 90 units as normal loss. which does not have any scrap value. We now see that the total output units exceeds the input units by a difference of 70. That becomes our balancing figure for abnormal gain. So we have to value the abnormal gain. The abnormal gain is valued as if it was a good output. So when we total the input cost, material and conversion cost, we get 166. 166, we're going to divide that into 920 minus 90 to give us $200 per unit. So the $200 per unit is what we're going to use to value the abnormal loss, the abnormal gain rather, and to value the good output, to give us a total cost of 180 and total cost of finished goods of 180 as well. Clear?
Yes.
Now, in a process, we may have work in progress. Work in progress is simply work which is still continuing. So you started with some inputs. Part of those inputs are fully completed into good output, but part of them are not fully completed, but they go out of the process. So the work in progress has to go through another process before it can be completed. How then do you value the work in progress? Because they've all gone through process 1 or process 2 to go to process 2 and 3 respectively. We use what is known as equivalent units. So to illustrate in an example, let's assume we've got an input cost of $250. The input units are 300, which costs $250. These go through a process. After being processed, we've got finished goods of 200 units, and we've got work in progress of 100 units. This work in progress is 50% complete. So it needs another 50% to be completed into 4 units. So requirement 1, A1, using the usual cost per unit calculation, what would be the cost per unit? The usual is what we've been looking at all along. We said the cost divided by what? The output. In a situation where there's no loss. So how much would that be using the normal? The cost is $250. The total units is 300. So 250 divided by 300 will give us 0.83. So the 0.83 is what we are going to use to value both the 200 units of finished goods in the 100 units of work in progress. Is it clear? So the 200 units will be valued at 166, the 100 units will be valued at 83. What about if we use equivalent units? The equivalent units which are completed are how much? 200 plus 50. We're saying 200 units are complete, right? Mm-hmm. And then the 100 units work in progress, 50% of that is complete. So 50% of 100 is 50 units. So the equivalent units which are complete are how much? 200 plus 50, 250. So that is what we are going to use to get the equivalent units. So the $250 now will be divided with what? 250 to give us $1. The $1 is what we are going to use to value the 200 units which are complete. So 200 units times 1 will give us 200. Then the 50 units which are remaining as work in progress will also be valued at what? $1 to give us $50. Okay. The equivalent units which are completed are how much?
So it's 200 finished goods and sales, 100 units which are work in progress, 50% is complete.
Yes, the 100 units are 50% complete.
Mm-hmm.
So 50% times 100 gives us 50 units as complete, and 50 units not complete. So the 50 units which are complete, we add them to the 200 units of good output which is complete. So the equivalent units becomes what? 250.
So the cost is remain the same as the number of inputs now when coming at the cost per unit.
Come again?
So when coming at the cost per unit, the input cost is still remains 250.
Yes, the input cost still remains 250.
Then the inputs is the 200 finished plus 100 from 50% completed.
Correct. So we get $250 divided by 250 to give us $1. But when we come to value the units now, we only value the fully completed units, the 200, times the equivalent cost of $1, in the 50 units which are in progress, times $1. We're going to ignore the other 50 units which are 50% complete. Clear?